Welcome everybody. Today I want to talk about emerging architecture or architecture in an agile way. I always wondered how much architecture is actually necessary for IT systems. I mean, my teams often ask me or tell me, we have too much architecture. Let's just start. Let's just iterate. Let's just go on and learn. And on the other hand, I mean, I've built in my years a few things already. And I know how to not do certain things. So should that learning not be included from the get-go? Well, let's find out. There's a saying in the Agile Manifesto, it's Principle 11, basically, the best architectures, requirements, and designs emerge from self-organizing teams. So I want to talk about that today, and with a focus on emerging and best architecture. The other stuff is out for now, but let's look in what is emerging actually. So if you look at it, what it means, emerging means, well, it appears. It wasn't there before, it just is there now, or it evolves somehow. So it just comes up, it grows, so to speak. What is architecture then? Architecture, we all know these beautiful architecture drawings of buildings, super in detail. They show everything, how it will be, and there are multiple layers to it, like from the outside, from the inside, and also technical diagrams and architecture. And we obviously know our system, IT system architecture, i.e. boxes and lines, connecting boxes. And somehow they are the same thing or similar thing. But architecture, in a nutshell, is about major pieces of a system. This is what you want to show, like also the interactions. And you do architecture for someone else to know what is supposed to do. That has like more specialized knowledge and less overarching or overview knowledge of the whole thing. So it's a little bit of a division of labor concept as well. And what architecture focuses on is it's about the non-functional requirements, a lot of it at least. So what are those? It's like security, it's like scalability, it's like resilience, how you want to maintain maintainability, your stuff, how to extend. Do you need an extendable system, the extendability, compliance, maybe even usability to some extent. And this all is encompassed in architecture. And this is what you as an architect actually do and try to plan and figure out how to address those things in the best way. And we do like high level architecture, and this has its reason. Architecture should be as high level basically as possible, to leave implementation details up to the people who actually do the implementation. So, and there we come to an interesting question. I don't have a correct answer, so I would be interested in your decision, or no, your insights there. Like, does architecture demand in like how much detail you create in your architecture? Does this scale somehow with the amount of developers, people you have in your product? Like, for example, if you have 10, do you need more or less detailed architecture than if you have 100 or 1,000 developers working on the thing? I can argue somehow both, and for me it most likely comes down to how good the people are that are working with. The better those people are, the more I think good architecture decisions will actually emerge, and we will talk about that very soon, because that's all about, and in the agile architecture way, this emergence. architecture. But first, let's look a step back and think how some people did architecture in the past. And this was the big upfront architecture model. Like, before you start a new product or project, whatever, you do all the architecture work in the beginning. You figure out everything, you plan everything, and then you have a detailed plan. You can print it out on like this much paper and then hand it over and someone can implement it. Sounds really cool. I mean, you can also do a waterfall development plan then. All sounds amazing. It really fits well together. Only issue is it doesn't really work well for software product. Why? Well, I think this upfront architecture thing, the idea of really upfront coming up with everything and making the detailed plan is great if you know 100% what you're actually about to build. So if we build a bridge, like a physical bridge, like for a motorway or something, we as human species know how to do this. It's just another one of those. Like the statisticians have figured out, or they have all the formulas. They can exactly show you, okay, you need to use this material and have this load-bearing structure there, and then the bridge will hold for 100 years, 200 years, whatever. It can withstand these and that forces. Is that fine for you? Yes. Okay, we build it like this. So completely understood. And there's not much change in there. It has always an option for catastrophic outcomes if something changed, like steel was a different one, concrete was worse quality than we thought, it gets warmer than we thought, hello global warming. So all of those things wrecked the whole thing, but everything's equal, we just build a bridge. So in software architecture, in software engineering, you hardly ever to never build the same thing again. Why? I think even if you build just another shop, and we build thousands of those already as a species, it's still, we use different technology than we did before. We have different people with different skill sets in our engineering team. We have different customers. We might have different compliance regulations. We for sure have different security regulations or ideas, because this also evolves constantly. So you always have different kinds of forces from the outside who will change up your product. So you never build the same thing twice. So this is the idea why we say, okay, no upfront, we iterate. We want to do small increments, see if it actually achieves something and move on. This is the whole idea from Agile. And also we figured out, like in the beginning of a project, like 50% of all of our requirements are actually nonsense. They are wrong. We think, we need to scale up to this, but in reality, it might be way more or way less. We think the interfaces will look like this, but they evolve as well. So yeah, we don't do that anymore. We start small. But how small? There's another way you can fall off from the same horse, like we don't know architecture at all. I mean, the principle says self-organizing teams, best architecture emerge, so just move on. We start immediately, we don't think about all of those non-functional requirements, we take care about later. This. And sure, you can start fast, but you will pay the price usually. Every architect that is there, or every senior developer knows what will happen if you do that. If you do it like that, you start small and you rewrite fast. So if you do it, you will probably rewrite the whole system at some point, throw away most of the things you build. Yeah, it might be an idea if you have no idea at all what you are actually building and do a complete POC, maybe then. But it even then is worth to figure out super high level and non-functional requirements. So, and now what is the agile way of doing it? The agile way says, well, you start with the very small amount of initial architecture. You architect around those non-functional requirements, and you figure out the super high level, things that absolutely have to be there. If you have those, we build on top of them, and we look how those architecture holds up, and we postpone more in detail. Why we do that? Well, first we learn a whole lot more about customer, environment, whatever, in that time till we got there. The next point, which I really like, is you get the developers who actually have an issue at the moment because the architecture doesn't answer their question. You can get them at the table and they show you, look, we have this problem now, we need a solution for this issue. We talked with those people already, and this has this implication. So you can have way better decisions. So this makes total sense to make those architecture decisions later down the road, as long as they don't fall on your feet. If you postpone a decision too much, you will end up with a solution, but it will probably not be the perfect one, and you might have to do some rework. But even that is not the end of the world usually. So doing decisions late is a good practice. And yeah, maybe it's more of an art than a science. I still don't know. Another good point is that the later you do it, the more people will, the more your developers will also think about the issue, and there you have an actual chance that a very good solution actually emerges, because the people who are in the trenches, who develops the stuff, they thought about it and they came up with a good solution. And then you have this emerging architecture. You still have to look at your non-functional requirements and the broader architecture, if it fits in there, and then you can integrate it. But still, it's a very good way to get the teams and the very deep know-how into the architecture decisions. So, and if you want to know some evergreen tips about architecture from my 12 years of experience, watch this video. Thank you.